In the scorching sands of the Egyptian desert, in a place known as Wadi Al-Hitan, or the Valley of the Whales, a team of geologists was mapping the landscape. They were walking across what was once a seafloor, roughly 40 million years ago. But scattered among the dunes were bones that didn't make sense. They were pulling out vertebrae the size of tree stumps, massive elongated skulls filled with teeth that looked like saw blades. At first, 19th century scientists did what any reasonable naturalist would do when they saw a 60-foot skeleton with jagged teeth in the desert. They assumed it was a marine reptile. They named it Basilosaurus, which literally means king lizard. They thought they had found a real-life sea serpent, a mosasaur, or a cousin of the plesiosaurs. But something was off. The teeth were differentiated, molars, incisors, canines. Reptiles don't have that. Their teeth are uniform, and the skull had a blowhole, not nostrils at the tip of the snout. Then came the shock. This wasn't a king lizard. This was a whale. And not just any whale. This was a whale that broke every rule of what we thought a marine mammal could be. Because when they looked closer at the rear of the skeleton, they found something impossible. Legs, tiny, fully formed hind legs, complete with knees, ankles and toes. See, Wadi Al-Hitan isn't just a graveyard. It is a snapshot of evolution caught in the act. A frozen moment where life was transitioning from the land back to the sea. As teams recovered more skeletons, hundreds of them, one thing became undeniable. Basilosaurus was the apex predator of the Eocene oceans, but it looked nothing like a modern whale. Imagine a creature the length of a bowling lane, but skinny. It didn't have the bulk of a blue whale or the compact power of an orca. It looked like a giant, blubber-filled eel. News of its true nature changed paleontology forever, because if Basilosaurus existed, it meant that whales didn't just appear in the ocean, they walked there. But here is what I find fascinating. Why was this creature so weirdly shaped? Why did it look like a snake made of mammal meat? The answer hinges on the Tethys Sea. Step back 40 million years. The Earth is warm. There are no ice caps. The Tethys Sea is a massive, shallow, tropical waterway cutting through what is now the Middle East and Africa. It was a global shortcut, a warm bathtub teeming with mangroves, seagrass and early sharks. And in this environment, you didn't need to be built for deep diving. You didn't need thick blubber to protect you from the crushing cold of the abyss. You needed length. You needed to be able to undulate through shallow, complex reef systems and mangrove swamps. Basilosaurus was absurdly long. It grew up to 60 feet, but it was incredibly slender. And unlike modern whales, its vertebrae were hollow, filled with fluid. This means it wasn't a deep diver. If Basilosaurus tried to dive deep, its bones would have snapped under the pressure. It was strictly a surface killer. So here's the question everyone wants to know. How did the king lizard actually hunt? Well, forget the grace of a dolphin or the sonar precision of a sperm whale. Basilosaurus didn't have the brain power for echolocation. It was effectively deaf to the high-frequency pings modern whales use. It hunted with its eyes and its terrifying jaws. Biomechanics tell us that Basilosaurus had the strongest bite force of any mammal to ever exist. We are talking about enough pressure to crush the skull of a smaller whale like a grape. It didn't filter feed. It was a macro-predator. Fossil evidence shows stomach contents including large fish and even smaller sharks. But it didn't swim like a whale. Modern whales use their tail flukes for propulsion, up and down, powering through the water. Basilosaurus had a tiny fluke. It likely swam like an eel or a salamander, undulating its whole body side to side. It was a slow, serpentine horror, lurking in the warm, shallow waters, using its massive length to trap prey against the surface or the seafloor. And those legs? They were far too small to walk on land. They couldn't even support the animal's weight. But they weren't vestigial. They had muscle attachments. Current theory suggests they were used during mating. Claspers, to hold on to partners in the water, a remnant of their land-dwelling ancestors, repurposed for a life aquatic. So if Basilosaurus was the king of the Tethys Sea, the top of the food chain, why isn't it still around? Well, the answer is simple and tragic. The currents changed. Toward the end of the Eocene, Antarctica separated from South America. This opened up the Drake Passage, allowing cold water to circulate around the globe. The planet began to cool rapidly. The shallow, warm Tethys Sea began to close up as continents shifted. The tropical paradise that Basilosaurus ruled was disappearing. The oceans became colder, deeper, and more open. And here is the thing about being a 60-foot serpentine surface swimmer with no blubber. Cold water is your enemy. Basilosaurus couldn't regulate its heat in the freezing new oceans. It couldn't dive deep to chase the food sources that were moving into the abyss to escape the cooling surface. And it faced a new threat: modern whales. The ancestors of orcas and sperm whales were evolving. They were smarter, faster, used echolocation, and had compact bodies built for speed and cold water. Basilosaurus was a relic of a dying world. It was too specialized, too long, too dependent on shallow, warm seas that no longer existed. It didn't die from a meteor. It died because the ocean circulation system reset. And that should make us think, because Basilosaurus shows us that evolution isn't a straight line. It's a series of experiments. For a brief moment in Earth's history, the oceans were ruled by a walking whale that swam like a snake, a creature caught between two worlds. And then, just as the tide shifted, the king lizard whale vanished, leaving behind only bones in the sand to confuse us 40 million years later.